This makes it more affordable for more people to fly to more cities while protecting the planet.
Front of the engine, what we're looking at now is a turbine and a shaft that goes to the back of the engine. Now what this is what drives the fan or the compressor round.
The aviation industry is no stranger to innovation. But what happens when a new technology threatens to upend everything we thought we knew about flying? Airbus has unveiled its groundbreaking open rotor engines, and the implications are sending shockwaves through the skies. Imagine an engine so efficient it could redefine air travel itself, yet it's causing fierce debates among engineers, environmentalists, and even rival manufacturers. What secrets lie within this revolutionary design? Could it really mark the end of traditional jet engines as we know them? Stick around as we dive into the bold claims, the controversies, and the shocking truth behind Airbus's latest marvel. One thing's for sure, by the end of this, you'll see why some are calling it a game changer, while others fear it could destroy the very industry it aims to save. Ready to uncover the future of flight? Let's take off. Shocking transformation in the skies. Imagine gazing outside your airplane window one day only to find yourself staring at a view so unexpected. Open rotor engines with exposed blades slicing through the sky. Well, these engines are unlike jet engines which we have been accustomed to seeing. There is no smooth profile of the casing, just tremendous spinning blades without the casing sucking in the open air. The very sight brings you to question every assumption you'd ever made about aviation. But while one might think of that to be futuristic or sci-fi fantasy, this is precisely being worked on by Airbus right now, and could well revolutionize our flying. Open rotor engines promise significant fuel savings, up to 30% more efficient than conventional engines. Reduced emissions and noise reduction is still a work in progress. The technology currently faces challenges in noise control, especially for urban airports. That is what one could call taking flight into a totally different era, altering the course of the entire industry through open rotor engines. It's not only about performance. Jet engine technologies have remained quite static for decades in design. We've seen small improvements, but nothing that fundamentally changes the way these engines work. Now, Airbus wants to rewrite the rulebook by proposing a design so close to the revolution that it would hardly dare to touch the limits of what is possible in aviation technology. This exposed fan blade concept is already stirring up excitement in the two-dimensional space of the aviation world, but it is not without its hazards. What these engines will be like in the real world is another question. What are the challenges ahead? The future of aviation may be a lot closer than we think, and it all starts with this shocking transformation in the skies. Are we ready to see a new generation of flying? But what if this revolutionary design isn't just about changing how planes look? What if it's about redefining the entire aviation industry? Stay tuned, because the stakes are higher than you think. The game changer Airbus is betting on. Airbus is tackling greenhouse gas emissions by introducing flexible rotor engine concepts, aiming to revolutionize future aircraft designs. Airbus, partnering with CFM International, is going big on conventional open rotor technology, which is set to revolutionize the aviation industry by enhancing efficiency, reducing fuel consumption, and cutting emissions. This bold collaboration aims to develop a radically new engine concept for the aviation industry. By totally engaging in the design open rotor engines, in which fan blades are not encased but exposed, Airbus and CFM toe the line of definition in efficiency, performance, and sustainability of air travel. A success here could lead to the anticipated breakthrough in the aviation world. These promises are truly remarkable, with an open rotor engine offering a 30% reduction in fuel consumption compared to standard turbofans. That makes it really direct, since airlines will have considerable savings with respect to the jet fuel costs, which keep fluctuating consistently and heavily burden the airlines. These savings may result in airlines reducing their operational costs and even reducing fare costs for traveling passengers. Most importantly, this might have a very positive effect on the environment, making air travel more sustainable through more significant decreases in carbon emissions. An open rotor engine could make a significant contribution to reducing aviation's carbon footprint in an era of climate change. The ambition goes beyond fuel efficiency. It's about changing the industry's approach to sustainability. If Airbus and CFM can materialize this technology, then they will usher in the next era of greener flying, in which less fuel is consumed and by less pollution, less air is polluted. The open rotor engine design aims to revolutionize aviation by challenging conventional jet engine technology. In this way, Airbus and CFM do not only invent a new and unprecedented design principle for improving efficiency, but also make possible a more easily reachable future for air travel that is more affordable and greener. The gamble will pay off. Open rotor engines will define a new industry standard, and Airbus will have firmly established itself at the very forefront of the next generation of aviation technology. Exposed blades, exposed risks. The basic concept of an open rotor engine is exciting. Open rotor engines promise exceptional fuel efficiency and a significantly reduced environmental footprint compared to traditional jet engines, but they are not directly comparable to electric motors. One major trade-off in this transformative design is the exposed blades, which lack the protective casing found in conventional jet engines. They offer their own benefits, but also come with trade-offs. The introduction of exposed airfoil structures allows the optimization of airflow into the engines and hence thrust production. On the other hand, it presents many risks and concerns that need careful addressing. Of course, the biggest problem would be ingesting foreign object debris. In conventional engines, the casing serves as a protective barrier for the fan blades, helping to contain debris and maintain efficient airflow. In open rotor engines, there is no such casing. Thus, blades are at risk of coming into contact with birds, ice, or small pieces of debris, causing damage that can be serious or can affect the performance of an engine. And it makes the case for ensuring the engine in performing operation is safe under such conditions. They also need to thoroughly test the external structure of the blades. They will probably experience more stress and turbulence than their enclosed counterparts, leading to increased wear and tear. The materials of exposed blades should therefore be built out of something very strong so that they could withstand the forces that would apply at high speeds. Airbus and CFM, however, need to design advanced materials for achieving all this without compromising on safety and reliability for long-term engine use. Yet those possible risks will not deter Airbus. With extensive testing and simulations now underway to address these fears, they are stretching their imagination to find a way to reduce the hazards of exposed blades. From advanced materials to state-of-the-art safety protocols, even in the secure environment that such advances claim, the open rotor remains a massive bet with high stakes. For technology to work, Airbus must manage to turn the tide of these awesome risks and at the same time prove that the new open rotor engines can operate every bit as well, if not better, than traditional jet engines in terms of safety. The industry's worst nightmare. Noise is one of the greatest immediate challenges associated with open rotor engines. Unlike conventional jet engines, where the fan blades are housed within a casing, these have blades open to the air and rotating at extraordinarily high speeds. This revolutionary concept creates more turbulence and thus much more noise. The loud, rumbling sound that they create is going to make flying much more disruptive for passengers. However, the greater issue is the noise pollution it could cause, especially in cities with strict noise regulations. In fact, airports in areas with high-density populations have sound restrictions to protect nearby communities. Within many cities, noise requirements are stringent, and severe restrictions or bans can occur if the sound is too loud for an aircraft. Fan blades exposed to open air raise alarm bells regarding airport operations in urban hubs, where every decibel counts. By design, open rotor engines are almost certainly going to exceed established noise thresholds for these airports, presenting a possible deal-breaker for airlines looking toward an open-rotored version for day-to-day speeds. However, neither Airbus nor CFM International is backing down from this challenge. Airbus and CFM have heavily invested in technologies for noise reduction, pushing open rotor engines closer to real-world application. These innovations work primarily on the consideration of shape of aerodynamic blade that can reduce areas of turbulence hit during high-speed rotation. optimizing the blade design and integrating some of the new sound-absorbent materials into Airbus's designs should push the noise down to what modern airports accept, rural and urban alike. In addition to aerodynamic and material innovations, Airbus is exploring noise reduction techniques, including advanced materials and optimized engine designs. These innovations aim to reduce the noise produced by the engines, making open rotors more feasible for both passengers and airlines. The programs will continue to develop solutions with new technology. Although noise is a serious challenge, Airbus is confident that innovative solutions will result into designs that meet or exceed the modern noise standards for open rotor engines, bringing about quieter, more sustainable air travel. Success in that area can really bring about the open rotor revolution is not only efficient, but far less disruptive. In addition to the technological advancements, Airbus is also collaborating with various regulatory bodies to ensure that open rotor engines comply with the stringent noise standards set by airports around the world. This collaboration aims to develop industry-wide guidelines for noise emissions, ensuring that these new engines can operate smoothly in both rural and highly populated urban airports. By working closely with authorities, Airbus hopes to secure the necessary approvals and overcome one of the biggest barriers to the widespread adoption of open rotor engines. With these efforts, the dream of quieter, more efficient air travel could soon become a reality, benefiting both the environment and passengers. Exposed blades and bird strikes. Open rotor engines have exposed blades which present significant safety concerns, especially in relation to bird strikes. A normal jet engine has a protective configuration in the outer casing which protects the fan blades from being damaged by debris. This is, however, not the case with open rotor engines. The damage from birds or foreign bodies meaningless through the engine could be far more extensive, thus making it one concern to be addressed for Airbus and CFM. Damage caused by a bird strike in a conventional engine can be severe, and the risks are even greater with open rotor engines. Airbus and CFM are relying on advanced materials and innovations to strengthen blade design and mitigate this risk. The new materials that are being developed have to be lightweight and very strong, therefore being capable of resisting bird strikes or other debris impacts without compromising your performance for the engine. These materials must be tested under extreme conditions to ensure the blades can withstand the stresses encountered during flight. Only through stress testing and rigorous research will they guarantee that the exposed blades are suitable for commercial aviation. Another major challenge is how to design an engine to minimize the possibility of a bird strike. Hence, in conventional engines, the fan blades are placed within the casing so that they are able to accommodate the energy coming from the bird strike. In the case of open rotor engines, where exposed blades need to be engineered to ensure that when they are attacked by a bird or object, that force is managed in a manner that prevents catastrophic failure. Airbus, therefore, has put an emphasis on designing blades that can better absorb these impacts through not only strong materials, but also innovative shapes which minimize the risk of damage. Definitely, there still is some safety issues concerning the open rotor engine, but that does not stop Airbus and CFM. They have put their open rotor engine through hellish tests and simulations as they keep pushing the boundaries of open rotor engine safety. The goal is to design engines that are not only more efficient and environmentally friendly, but also just as safe, if not safer, than conventional jet engines. By investing heavily in advanced technology and stress testing materials, Airbus aims to ensure that open rotor engines can meet the highest safety standards, allowing this revolutionary design to become a safe and reliable option for the aviation industry. While safety is a top priority, there's something even more groundbreaking at play here, a future where flying is not just efficient but revolutionary. Let's explore how this technology could reshape the skies forever. A cleaner, cheaper, quieter future. Open rotor engines are more than just a new design. They promise to create a different future for aviation. Cleaner, cheaper, and quieter. The technology seeks to facilitate an engine that allows the airlines to save money while minimizing the carbon footprint of the aviation industry. An under-promise of 30% reduction in fuel consumption could mean savings for the airline. especially for an industry where fuel often takes a major part of the operating cost. This efficiency could translate into reduced ticket prices for the passengers, making air travel cheaper and accessible. Also, the environmental implications of open rotor engines can be very deep. Aviation has one of the highest stakes in terms of global carbon emissions, and the pressure to reduce that impact is mounting. Open rotor technology can be touted as a leading edge on the possible completely green aviation world, given that it can be expected to record fuel consumption extremely below levels anticipated with reduced emissions. These conditions are important in a world where airlines and governments become increasingly stringent with respect to environmental regulations, and any technology that may cause pollution reduction is not put aside. Open rotor engines could very well be the key to air travel sustainability in the future. Airbus is also requested to address one of the most concerning issues in aviation: noise. A concern for noise presents itself with the open rotor engines, which expose blades but have significant advances in technology that reduce noise, making them more efficient and quieter. Airbus is thus considering the various actions taken toward the shaping of this engine to run with minimum disruptions. The redesign of blades, the use of sound-absorbing materials, and the concepts for active noise cancellation are some of the actions being considered. First aim is to reduce voice of open rotor engine such that it would fly in urban airport where very strict noise regulations exist, thus not disturbing the surrounding people. Turned dream of a much cleaner, cheaper and quieter future, yet could completely metamorphose the way humans think about flying. Think of not using too much fuel, emitting less, and fly over cities without annoying the noise pollution. All these ideas may turn into reality in the forthcoming years, with the splendid advancements being made in open rotor engine technology. TuneHub, Airbus and CFM are more determined to making this happen as the technologies still have a long way to run. This dream could transform the aviation industry, leading to a greener, cheaper and quieter future for air travel in a short amount of time. Will Airbus succeed? As the aerospace industry stands on the brink of destiny, carving out the path into its future with the ambitious open rotor engine technology launched by the Airbus, the most important question seems to be whether Airbus can make such a revolution come true. Potential advantages have their own counterparts. Potential difficulties are also huge. Fuel-efficient engine is not the only objective for Airbus. It is targeting an industry which is hitherto dependent on decades of established technologies. The stakes could not be higher. Airbus could potentially transform the entire aviation industry with success. But failure could delay years of building more innovative technologies at the very least. This was one of the major hurdles for Airbus to overcome, the traditional attitude with which the industry views itself. For the past few decades, jet engines have followed a certain path. Airlines have called manufacturers and regulatory authorities into these types of arrangements. All are contributors to this deep-rooted system. The open rotor concept completely breaks the norm, and the industry might need more than technology to turn the industry itself around. It might have to change how airlines and regulators perceive what is possible. An advanced assault for Airbus will be to convince stakeholders that the open rotor engine is not merely safe and efficient, but also envisions the future of flying. The challenges associated with blade exposure and bird strikes are serious obstacles. While Airbus is keen on a lot of testing in this area, it cannot be guaranteed that these solutions will work to satisfy the rigorous safety standards imposed by aviation authorities. Safety has never been given up in history, and missteps in this area are disastrous for Airbus and the rest of the industry. Blades, although made with state-of-the-art materials and improved safety measures, are at risk, and unless managed well, this could misfire into jeopardizing the entire project. The market response would also highly determine whether Airbus's open rotor engines would live or die. After all, airlines survive or implode on cost efficiency and profits. Should open rotor engines make good their promise of surefire reduction in fuel consumption and cut costs, perhaps airlines will be quick to embrace the technology. Otherwise, if they fail to deliver, or if noise and safety are seen as hurdles to adopt changes in the industry could easily cling to its conventional, safer technologies. The future of open rotor engines range from pure engineering to whether the industry is prepared to take on this bold new direction. Moreover, the public perception of open rotor engines will play a crucial role in determining their success. Passengers accustomed to the familiar hum of conventional jet engines may be hesitant to embrace this new technology, especially with concerns over noise and safety. Airbus will need to not only prove the performance and reliability of open rotor engines, but also build trust among travelers and the general public. Effective communication, transparency, and extensive testing will be key in shaping how these revolutionary engines are received by the broader aviation community and the flying public. If Airbus can overcome these psychological and cultural barriers, it could set the stage for a new era in aviation. How open rotor engines could reshape aviation. Indeed, if Airbus manages to bring its open rotor engine technology to market, it will have a seismic impact across the aviation industry. This changing technology is a complete paradigm shift for airlines in terms of their aircraft operating efficiencies, providing the capacity for huge reductions in their fuel usage and operational cost. It could save anywhere from 20 to 30% in fuel spending, thus saving airlines tens of billions of dollars yearly, and also bringing ticket prices down for passengers. Such savings in fuel could really make profitable low-cost routes for airlines, widening the access of air travel to more people, and possibly changing the mindset people have about flying in general. On a broader scale, it is expected that this technology will also affect global aviation networks. As they reduce emissions and fuel costs considerably, open rotor engines will give rise to new operational horizons for airlines flying longer distances but at lower prices, thus making unprofitable routes feasible. International flights that consume high-octane costly fuel may also be rendered more economical, thereby increasing airline reach, alluding to distant destinations. On the other hand, short-haul flights might also be made affordable, so that regional flying does increase with more flights on small and medium-haul routes. Besides finding the economies of open rotor engines, the environmental effects can be vast. Aviation, being a major contributor to global carbon emissions, can help in bringing economy-efficient machines into the play that delve much deeper on environmental sustainability as true solutions to combat climate change. It is well in sync with the increasing push for global sustainability in every sector of society by promising lower emissions with open rotor technology. Airlines chasing a reduced carbon footprint would be flocking to this national technology as environmental rules tightening became a bigger and bigger factor of life. Clean air travel would probably overhaul public perception toward aviation, offering an alternate green solution to the thirsty aircraft of today. Eventually, while open rotor engines are being adopted, the entire industry may experience technological innovations. It may unleash possibilities in other areas of aviation, while Airbus and CFM are compromising limits with this novel engine design. Noise-reducing technologies, more efficient airframes, and even greener fuels are just some areas where the whole impact of open rotor engines stretches far beyond the engines themselves. This technology may not only change flying, but could lead to a complete transformation in how we think of the future of air travel. It may also define the signature around which the next century of aviation might be formed. Changing the world or just making noise? Airbus calls it a gamble almost as bold as the most audacious of bets, including in any business. It could revolutionize the aviation industry for decades to come or end as just yet another costly experiment. Airbus is betting that this is the ultimate way to redefine the future of air travel, because the aviation sector is under tremendous pressure to cut down fuel consumption and emissions. However, the gamble involves some risks. The open rotor design virtually challenges everything the industry knows about jet engines, from exposed blades to all the noise and safety concerns that come with them. The stakes are quite high. If successful, it could set a new standard for sustainable aviation. If not, it could be a huge reputation deep cut of costs to deal with and severely impacted transfer into the future of greener technologies. From the safety aspect to the noise aspect, every single step of the development would be a potential minefield from there to answer all the required safety standards to overcome noise regulations. The travel of open rotor engines is paved with technical barriers that Airbus must navigate carefully toward the successful end. Conventional jet engines are so entrenched in the market, and the psychological hurdle to overcome in getting the industry to buy into a design that is so far removed from the way everyone is used to traveling is enormous. Both airlines and authorities, as well as OEMs, have a lot invested in and are familiar with the old. So this won't be quite about having a new engine. The culture has to change to have open rotor engines' future. Airbus has, for the time being, undertaken what could prove to be a costly gamble in a very uncertain field, inventively breaking new ground. The company has long set the trend in pioneering more advanced and various new technologies, from quiet engines to fuel savers, to the next stage of its technology hurdles, namely the open rotor engine, noise reduction, advanced materials that ensure safety. By investing massively in that, Airbus is attempting to reduce the risks. But whether it really will lead to new breakthroughs in aviation or only add to noise will depend on Airbus's overcoming the fundamental issues that have always plagued open rotor designs in the past. It could be the gamble that ultimately rewrites the history of aviation. Or it could be a tale of lament, might illustrate the limits of possible innovation. The initial excitement surrounding open rotors could very well turn into disappointment when people realize that success hinges on transforming the industry itself. A challenge not only daunting, but also one that resists revolutionary changes in already established empires. So, what happens if airlines fail to embrace this technology, but continue to dream about it? Using industrial metaphors, the adoption of open rotor engines may place the industry under unprecedented scrutiny. As Airbus takes its bold leap into the unknown, the real question is, will this gamble redefine the skies, or will it crash before it takes off? The answer may be closer than we think. The future of aviation is in the air. The future of aviation hangs in the balance as Airbus continues to try to develop their open rotor engines. With every step, the aviation industry inches closer to a more efficient, sustainable, and quieter way to fly. If it works, the possibilities are immense. Could this be the time diary, and this could be the beginning of a green revolution in the industry, where airlines adopt greener technology, cut fuel costs, emissions, and charges for customer fares? But, lo and behold, the dream of cleaner, cheaper air travel has now become a reality, opened doors to an international aviation network, corresponding to some of the most pressing environmental issues of today. There lies within this matter the further challenges ahead. Airbus's ambitious blueprints for future progress are thwarted by tough challenges regarding the safety and noise and acceptance of the design by the industry. Open rotor could just be that breakthrough for aviation, which every safety, noise, and societal acceptance level would have to be more carefully entered as they present a number of risks. Experimental engines and materials with promises of efficiency gains will probably not be tested against the same rigorous demands expected in the aviation industry. Perhaps it is flight, or some new process that is about to crash in just a time before really making its impact. In fact, it is evident that the future of aviation has loosened its conservative grip over time. Open rotor engines have potential that can lead to paradigm shifts in flying habits forever if transitioned through their technological challenges. In other words, this is not simply a new engine form. It means a departure from traditional bets in thought that surround air transport. New conceptualization based on greener, cheaper, and more effective future for industry using customs of thinking will raise challenges against the status quo while giving an opportunity for what may become one day the air transportation of the future. Yet again remains the biggest question. Will the industry go along with this bold new direction? Or will it keep on hugging the engines of the past? Looking to the future, the next few years should bring vital insights into how flight will evolve. Whether the open rotor engines of Airbus herald a new chapter in the book of aviation, or simply fade into its background, will depend upon creativity, collaboration, and willingness on the part of the industry to effect change. One thing is for certain, the sky is the limit, and the future of flight is, to be sure, still very much in the air. The question is, how will we get there? Only time will tell. If you enjoyed this deep dive into the future of aviation, don't forget to like this video, comment your thoughts below, and let us know if you think open rotor engines are the future of flying. Subscribe for more exciting content, and hit that bell so you never miss out on the latest in aviation and beyond. And don't go anywhere. Check out our next video on the screen for more mind-blowing insights. Thanks for watching.